V45 crankshaft is the most innovative design for the industry. And as a comparison, this is a crankshaft from a four-cylinder 1929 Alto quad. And this crankshaft is very much industry standard. 1 and 2 and four-cylinder cranks in that time all basically look like this.
Looks kind of Neanderthal compared to that.
Yeah, and then so here we are, the Johnson compared to the Johnson V45 crankshaft, which is, as you can see, much shorter, okay, way shorter in design. And that has to do with the roller bearing crank needs less crank pin space than the plain bearing bronze crankshaft, bronze connecting rod type crankshaft. This, of course, is an easy, pretty industry standard forging. This is very complex, but nevertheless, it just allowed for just great potential horsepower. Good crankcase stuffing with the full circle, whereas this open type crankshaft, that's all wasted airspace, and that on a two-stroke, when you're looking for good, crankcase suction and crankcase pressure for scavenging is valuable volume.
Right.
To be able to use
Very
that volume.
Draft, yes.
So that's the comparison, just to show how innovative this crankshaft really is.
You're on.
Okay, so we just talked about the forged steel connecting rod, and the I believe we talked about the little roller bearings, the little 1/4-inch diameter roller bearings that were not necessarily Johnson's innovation. The Evernude company in 1928 introduced that same technique in their 1928 Speedy Twin and 1928 Fast Twin. Johnson went to roller bearings later in 28 with their Giant Twin and their PR40 Class C race engine.
Oh, so the Johnson went to it in the same time period then. I didn't know that.
Well,
and this is, again, as you can see, that's the caged roller bearings. That's half of one right there. And they come apart and whatever. They're extremely good.
yeah,
Very
but
impressive.
so, I mean, Evernude already had a very successful, half season already with that.
Oh, they did? Before they came out with the Giant Twin with the bearings?
Well, the early Giant Twins actually had huge bronze rods.
Okay, all right.
And they got away from that fairly early. They realized that there was, going to be big trouble with big power. And, that whole bronze rods on hardened steel crankshafts is a good technique. But the issue is all around lubrication. And as RPMs, as racing and more performance, became prevalent in the later 1920s, that as speeds increased, the crankshaft would tend to whip the oil off the places where you really wanted the oil. So you really needed to add lots and lots of oil.
So as RPMs were rising, we were well out of the 1,000 RPM or
Right.
1,000
Yeah,
RPM
right,
and below.
right,
We were
right.
out of the rowboat era and entering the
Right.
go-fast area.
Right. And the roller bearing has the wonder of not needing as much lubrication. And the whole roller bearing technique really is borrowed from the motorcycle industry. So the earliest motorcycles came right off with roller bearing
Really?
crankshafts and rods. And that was because they didn't know how back then to put an oil sump on a motorcycle engine. If you look at any of those early motorcycles, they have a very round crankcase. Even though they're 4 strokes, they looked like a 2-stroke crankcase. They had no extra material. So for many, many years,
Well, that's like we were looking at that engine down there,
Waterman.
in the Waterman in the last What's Inside series, and that same crankcase is what they used on the motorcycles, but they were four-stroke, you're right, I forgot about that. I
So
thought
there
were
was
two.
no real official lubrication system on a motorcycle engine, other than a sight feed drip oiling system. So there was a tank that had the oil in it, and there was a line and probably a flow control valve and a little sight window, and the line went lighted right into the crankcase, and it would just drip oil in, very much uncontrolled. But that's the wonder of a roller bearing, is it doesn't need a lot. It just
Okay.
needs something to be present.
Okay.
So of course the oil drips in, it gets whipped around in the crankcase, and I think that those crankcases would, over time, would start to fill up, and they'd just have to drain the extra oil out.
Okay.
So anyway, that, I've been told by motorcycle people, antique motorcycle people, that roller bearing was right from the beginning. They did that, and actually, I'm also told that Harley Davidson, even in the early '30s, when they came up with a feed pump and a scavenging pump system. So for all that time, they just dribbled oil in. Anyway, so we talked about the crankshaft, but the greatest innovative thing of the long list is this roller bearing. Sorry, rotary valve, and that's allowed an induction system that added very good horsepower.
So this gear right here was driven by the crankshaft?
Yes.
Okay. So we're looking at, what you're showing us right here is the engine side of the rotary valve enmeshed with the,
Yep.
okay, very good.
It's timed
Yep.
1-to-1 gears, so
Yep.
that the valve opens at the correct time and closes, of course.
So
at
where
the-
did this come from?
Yeah, I don't know. I don't
So
know.
you think Johnson might have been the first one to do it? Possible.
Possible.
But they must have caught some sort of an idea from somebody somewhere. That's the first question
Yeah.
I have to ask you. And why did later on they went to a 2-to-1 very shortly after they came out with this?
Right.
A 2-to-1 turning. Why was that more? Why did that work better than 1-to-1?
Yes. So the fuel passage on a 1-to-1 is a little bit torturous, let's say. So that the fuel air comes in through this integral manifold and has to line up with a port here. So it
comes
was
in
yeah.
here and has to come out through here.
Yeah.
Right. Okay.
Whereas with a 2-to-1 rotary valve, then they could put a port in such a way that it
Directly in front.
directly straight shot through.
Ah,
Yeah.
okay. I've always wondered that. Thank you.
Yeah. Now, one little piece on rotary valves is that there was an engine before Johnson that had a rotary valve.
Oh, there was. Okay.
Yeah, and it was the Aerothrust, that air-cooled air propeller. They
really?
had a disc, a crankshaft disc.
How much
rotary
before
valve.
do you think?
That would have been 1917, 16, 17.
So it was quite a while before.
Way before.
All right. So
And
we're
the question
talking-
is, did Johnson even know about it? Did Johnson?
They must have. I think those guys in those old days,
Yeah,
it was a rarefied society.
Yeah, I suppose.
I'm sure they did.
Right.
I mean, that would be my guess.
So rotary valves did exist
Okay.
before this.
But that's still incredibly innovative for the outboard world, I think.
Totally innovative.
Yeah,
Right,
yeah.
right. And of course, with the big crankshaft required a big crankcase, and it's quite the casting. And being a 2-stroke, it needs a center bearing to isolate the 2 upper cylinders from the 2 lower cylinders to be able to have crankcase compression and all that. And it's an interesting center bearing held in by a big snap ring. Other features, of course, aluminum pistons by 1929 were pretty standard in the industry. I think Elto still had cast iron pistons on their Speedster and some others, but most everybody had gone to aluminum by then. And,
Are you inferring that Everett maybe had one foot in the ancient times?
oh yeah,
Outboard
I mean,
world?
there's good reason to stay with a cast iron piston. for
Because
sure.
it worked,
It worked very, very well,
and he sold well.
yeah.
Yeah.
And, you know, the other thing about cast iron pistons on a two-stroke, if you have a good fit between the cylinder and the piston, you have less crankcase compression leakage. In other words, it can pull
Yeah.
a nice clean vacuum without any blow-by along the skirt.
Yeah, that would make
And the
sense, so
exhaust
you've
port.
got two materials the same.
Yeah,
you don't have that
so
expansion problem.
there is some, you know, some good reason to stay with a nice close piston to wall clearance. I think one of the downfalls of the Indian Silver Arrow outboard is they came through with like more than 10 thou, even 12 thou I've seen piston to wall clearance. Okay, and a little short stroke engine, that doesn't give you a lot of good crankcase scavenging.
My guess is that the Hartford Gray did not have that clearance problem.
Yeah, they might have.
You think? I don't know, that engine very much impresses me.
It's interesting
The
because
Indian
they in the
Silver
brochure,
Arrow.
they talk about, in 28, they talk about cast iron pistons standard and aluminum pistons optional. You had your choice in 28 with the Hartford people.
All right.
Being a small company,
Yeah.
it was almost like a custom build, really.
Gotcha, all right.
Another innovative feature on this model V45 is cylinders with detachable heads. And that's, most of the industry had integral cylinder and cylinder head in one piece. And that's kind of a nice thing. You don't need a head gasket. It's, you know, there's probably less separate parts to machine and deal with and all that.
Yeah, but you can make them go faster when you've got a detachable
So,
head.
the nice thing about the detachable head is you can see the contour, the piston crown contour in this casting. And that allows for a higher compression ratio, because if you have just a cylinder with just an open end, an end that wasn't contoured, you'd have much less compression. And so, yeah, that's another, you know, really advanced feature. So, you know, part of that, I think we talked about the center.
Yes, you
bearing.
did, yeah,
So,
you
okay,
did.
fine. So anyway, that's kind of the internals, the power head internals on this Johnson. And Lincoln is going to talk about the lower unit.
Well, first of all, I want to talk about this midsection, because in the Giant Twin, my understanding is that this piece broke off.
Yeah, it broke
along-
off somewhere around in here.
Right up in there.
Yeah.
And so I asked Bill if he thought this had been beefed up. I've never worked on a Giant Twin, so I really don't know anything about them. But I've never heard of a problem with a V45 breaking, and so they must have beefed this up quite a bit. And Bill says yes, they did. So
But part of the Giant Twin problem was some coring that was inside here that allowed, and it had that reverse lock feature, because people thought that the Giant Twin needed to do 360-degree steering.
Yeah.
Okay, it was part of the, it's good for the light twin.
Right.
The Giant Twin, you're going to want to spin that thing around on the transom all you want. And because of the coring involved in that bell that was on here, it made for the weak spot.
Ah, okay, very good. Yeah, spin around.
Right.
Okay.
And,
So
now, are you going to talk about the exhaust? Or are you going to talk
no,
about
you
that?
talk about the exhaust. That's go ahead. It's
Finish.
okay. So this is the lower unit. It's a two-piece casting, which in the old original ones it was a one-piece, and it's well made, well cast, and the big thing with this was that the gears had ball bearings, significant reduction in friction, and the prop shaft had a bronze bushing in front. As Bill has told me, the bronze bushing was a way to seal it, other than the seals at that time period weren't very good. So the bronze bushing on the front, just before the prop itself, was the same in this. You can see it, and you chime in, Bill, if you think of anything. You can see the bronze bushing right here, and that's the after end of the lower unit. The other thing that's kind of interesting about this is loading this. You don't load it in through this way. The shaft goes in that way, but the gear and the bearing, well, it's a little stuck on here, but they come off and you drop the gear in through. Yeah, it's still pretty stuck. Okay, there we go. So, all right, we can take and you have to drop the gear in. I'm not exactly sure. There we go. And then you put the shaft through it, and then you put the bearing on the end of it, and then there's a series of caps and screws which you adjust the tension of the bearing so you get the right gear lash between the forward gear and the pinion gear, which is right here. So it's, I'd say, fairly innovative. I'd say it's something very new in the industry, to me,
Right.
doing it this way.
Right.
But they felt the strength and so forth. We have the bearing right here is actually right at the very top of this lower unit casing, so we don't have a lot of movement and a lot of worry about the two halves shifting a great deal. They're held solid with each other, and I think probably what it meant was that the gears didn't fail, and they worked well. It transmitted power very well and very precisely with very precise gear lash, which I think on the earlier stuff was probably not so good. And lower unit gears even were a problem right up through the 80s. Having them set up properly, gear lash had to be good, and if you didn't do it properly, the lower units would fail. And this obviously was an attempt to transfer that power out of that power head very, very well.
So, but we'll talk a little bit about failure. And there was great resistance in the industry at the time to go to away from bronze bushings in a lower unit and into ball bearings or roller bearings. And that is, they have no tolerance for water. So the whole idea with a bronze bush lower unit is that you can operate basically in pretty hostile conditions and still stay together. And so with not good seal technology at the time, it was really difficult to keep water out of a lower unit. And so that, and you can see right here,
It's frozen.
what happens when there's water in the lower unit. So it becomes more of a maintenance issue, more critical of maintenance, that check the oil, drain the water out, put new grease in, or whatever you do. And that's why we see a lot of rusty stuff. So now we can talk about the exhaust system.